Welcome back, ladies and gentlemen. In this video, we are going to have an objective of multiplying and dividing complex numbers that are a little bit different than what we have seen in previous times when we were just saying, hey, multiply a plus bi times another, c plus di. We're going to think about how can we multiply them when they are in their polar forms instead of their basic complex standard form of a plus bi. And so good news is we have a basic kind of formula that we're going to use to do this. Now, I am not going to necessarily show you the proof as to where this comes from. I'm just going to ask that you kind of take it from me for right now. In your textbook, there is actually a proof that kind of goes on into it, but this is going to be very cut and dry and just to the point as to this is how it's done, this is how we're going to utilize it. So I apologize for not having any kind of cool application that goes along this. This is a little bit more of just rote memorization type of use in this video today. And so what we need to understand here is when we are thinking of a complex number in its polar form, I'm going to call the first one Z1, and that's going to be polar form of r sub 1 times the cosine. That looks like a big old C. Let's get that out of here. Times the cosine of theta sub 1 plus I times the sine of theta sub 1. And if I have a secondary, let's change colors. If I have a secondary complex number, we would call that guy r sub 2 cosine theta 2 plus I sine of theta 2. And again, if you're looking at any of this and you're like, where did he just get all of this stuff from? One, this is understanding and assuming that we have a background as to how to convert from polar form to complex standard form or vice versa. And so this is what we kind of determined in our previous video there. So what we can say is that I can go ahead and utilize these two formulas to multiply Z1 and Z2 together. And what this is going to ultimately end up being is that we could take R1 times R2, and then we can go ahead inside of those parentheses, we can add the two direction angles. So we could say it's cosine of theta 1 plus theta 2 plus I times sine of theta 1 plus theta 2. Now, similarly, if I wanted to go ahead and divide, take Z1 over Z2, I would take R1, divide that guy by R2, and then I could go ahead and say that cosine of theta, instead of adding, I would just subtract. All right, and so these are our two critical formulas that we are going to be utilizing in the rest of this video and that you will need as we continue to move forward in our discussion with operations based on complex numbers in the polar form. So let's take a look here at our first example. We want to multiply the following out. So to take Z1 times Z2, I will take the 2 radius, which is, or the modulus, however you want to call it, right? 25 root 2. And I will multiply that guy by 14. Inside the bigger set of parentheses, or you might want to use brackets, you can take cosine of negative pi over 4 plus pi thirds, and I times the sine of negative pi over 4 plus pi thirds. And honestly, all I'm doing right there is just following our basic formula. So we have Z1 times Z2, 25 times 14, 25 times 14, let me do it real quick, 350, root 2. And so since negative pi fourths and pi thirds obviously do not have common denominators, we're going to have to make sure that we get that. So we're going to have a common denominator of 12. So just listen, I'm not going to write it down. You have negative pi over 4. In terms of 12 as a denominator, we're going to have negative 3 pi over 12. And then pi over 3 is going to be 4 pi over 12. So it's really negative 3 plus 4. So that just simply gives us a positive 1 pi over 12, or just pi 12ths. And of course, that'll be in both cases there. All right, so at this point, you're going to use your calculator to actually find out what these values are. So you will distribute and distribute. And just to kind of save a little bit of time, I've done these calculations already. They come out to be about 478.1 for our real number. And then for our imaginary number, we get about 128.11 I. And so that would be the standard form, as it's asking for, of what was the polar form. Let's take a look here at a division problem. So we want to do the same concept, except this time we want to divide it and leave it in our standard form. So z over z, z1 over z2, will end up being 2 root 2 divided by 6. And then instead this time we are just going to go ahead and subtract. So we get z1 over z2. 2 and the 6 will cancel to get us square root of 2 over 3. And then we get cosine of 135 minus 300 is a negative 165 degrees. And then just going to go ahead and simplify that out. And again, these can be done in your calculator, so make sure you are in degree mode if you were in radian mode from the previous one. So then we will once again distribute on through. And cosine of negative 165 times the square root of 2 over 3 approximately came out to be about 0.46 for the real number. And then the distribution to the imaginary number came out to be about a negative 0.12 I. So this would be it left in standard form as a complex number as it asked.